Hey everybody, welcome to another video featuring your favorite disembodied head of evangelism, me. In this video, I'm going to talk about my most recent side project and how much fun it's going to be. For the past number of undisclosed years, I've tested out new technologies and languages by trying to make a mud out of them with varying levels of success. Now I'm ready to apply every one of the buzzwords in the search engine AI soup to creating a mud. The old school version of myself would have just created a blog post about these efforts. I would spend days typing so people could spend minutes reading. But the new, hip, trendy me is making a video with an AI avatar and voice. I'm an influencer now, right? Right? For those of us who learned how to use computers before the internet could be found everywhere from your phone to your toaster, online text adventure games were the coolest things around. We called them MUDs, or multi-user dungeons, or multi-user dimensions, depending on who you ask. Using an ancient artifact known as a modem, you would dial into your favorite internet provider and then use Telnet to play your games and interact with your community of fellow mudders. Once a player graduated to become a wizard, either by finishing the game or being selected by another wizard, they would then be able to create new content. Young developers like myself at the time would then write game content in code using languages like LPC or some Lisp-like scripting languages. More modern player-generated content is often written in languages like Lua or even portable formats like WebAssembly. So, how can I leverage AI technology to help players create content inside these MUDs? It should be as fun to build as it is to play. While there are a bunch of possible ways to use agents here, I think the most obvious and the first one I'll be tackling is in describing game object behavior. The idea is to use an agent to convert natural language behavior descriptions into some kind of actionable data that can then be used at runtime. When I'm designing products, I like to start with the ideal user experience and work backward. In this case, I want to go through some sample commands that a wizard would enter into the game to create their own content. The first thing wizards need to do is to create a template or a blueprint for the object. If this was object-oriented programming, you would think of this blueprint or prototype as a class. Here, using @create constructs a new blueprint in the specified namespace. Some other things that I want to be able to do with these blueprints is supply descriptions. Here, I'm using the @describe command to supply the description for this cloak that can only be found within Helm's Deep. The ls command helps to visualize that these blueprints are separated out into a hierarchical namespace tree. This makes it easy to distinguish between the decidedly magical Helm's Deep cloak and some other mundane, tattered cloak found in some dirty inn like the Prancing Pony. Crucial to being able to distinguish between two similarly or even identically named objects in the immediate vicinity is the ability to supply adjectives for these blueprints. Here, you can see that I've added 3 adjectives: strange, magical, and blue. Assuming that an LLM is being used to interpret user intention, these adjectives will give it enough context so that it can understand that where cloak, where blue cloak, and where strange blue magical cloak all boil down to the same user intention. Now we're getting to the fun AI bits, the work that will be done by models that would have been done by manually coded parsers and lexers in the past. Unless you're building a game all about parsing and lexing, nobody wants to deal with that stuff by hand. More importantly, We want wizards to be able to supply natural language descriptions for the behaviors they want, which means going beyond lexing and parsing and deriving intent and meaning from language. This is what LLMs were made for. There's a bunch of really cool stuff happening implicitly in this sample output. First, we're taking the user's description of object behavior, wearing a cloak, and using an LLM to generate the corresponding JSON data. Then we use a model, which could be a totally different one if we choose, to summarize that JSON data in a user-friendly way. This gives wizards a feedback loop so they can tell if they're accurately describing the behavior and if the model has accurately interpreted that behavior. No code had to be written here, and the wizards are blissfully unaware of the mechanics of what's happening behind the scenes. I try and make this point whenever I talk about programming agents and working with LLMs. Prompt and context engineering is the key. If you get the prompt wrong, it won't matter how cool the rest of your agent is, or what language, framework, or platform you used. For this particular prompt, I think I went through about 20 or so iterations to gradually refine it until it gave me the results I was looking for. This kind of preamble should look familiar. We tell the model its role in the universe and what we expect of it. These preambles often include the most important and broadly scoped guardrails. In my case, iteration over bad prompts made me add the rule not to omit or summarize behaviors. Further down the prompt, I give it a list of the supported behavior triggers. By providing this list, I'm giving the prompt a much better chance at making inferences. If I add a new type of trigger to the game, then I can add the code to perform the behavior. And I just have to add it to this list to let the LLM use the new behavior in its analysis. In addition to determining which trigger is mentioned in the wizard's prompt, we also need to figure out what actions should be taken in response to that trigger. In this initial version of the prompt, I only have two actions: sending a message to one or more players and setting the visibility of players and NPCs. As with enumerating the possible triggers, enumerating the possible actions limits the range of output for the LLM, making it far more predictable and reliable than if it was dealing with the set of all possible actions everywhere. To further narrow the scope of the LLM's output, I supplied it with this table. During my first few iterations of the prompt, the model had a terrible time trying to figure out the target of the actions being taken. It kept issuing actions that would send a message to the cloak and set the cloak's visibility to 0. I tried verbosely describing what I wanted, and that made things worse. Instead, I built this table giving hints as to who the actor parameter could possibly be for each action. This makes inference more predictable. This huge pile of text is basically a set of rules that I created from consistent failures. Each time the model would continually produce the same wrong result, I would add a rule in here to help clarify. It may not be perfect, but I get the right JSON output from the model pretty much every time now. Still more talk about prompts? Well, I did say that prompt and context engineering were the single biggest contributing factor to success or failure. While I haven't built this part of the game yet, I also want to use a model at runtime. Players will be typing things like wield dagger or stab Kevin and expect the game to perform accordingly. In the olden days, back before the Great Wars, I would have manually parsed player input and enforced an unreasonably strict input pattern, like the way King's Quest used to be so unforgiving about kneeling before the king. Now, I plan on gathering a list of objects in the command issuer's inventory and in their environment, such as the room they're standing in, and sending that as context to a prompt performing object identification. With another minimum temperature prompt, I should be able to gather all the information I need to act on the player input. If we hide the text from the prompt, then this is all the code we need to write for a behavior interpretation agent written in Akka. Seriously, this is the only function we need to add. It should be illegal to be able to do this stuff so easily. So, what's next? Where do I go from here? If I'm being completely honest with myself, the most likely next step is for me to abandon the side project, casting it into the same roadside ditch as all of my other projects and expired internet domains. If, by some strange miracle, I continue with this, then I'm going to want to add a UI so I can interact with the game without using curl. Then I want to add more of the wizard commands so I can go from creation of a blueprint to instantiating it via the @conjure command.